Right, I will demonstrate tessellation for you. Now, tessellation is when you can join shapes together and it leaves no gaps between the shapes. So for example, here I've got a hexagon, regular hexagon, meaning all the sides, all the angles, corner angles are the same. So I can easily tessellate hexagons. Watch. Right, look. No gaps. There's no gap in that point, around that point. And I can continue with this. And so on. Now, in a previous video to do with polygons, you'll have seen the interior angle, the inside angle there of each of these regular polygons, regular hexagons, is 120 degrees. And you know angles around a point add up to 360. So 120 plus 120 plus 120 should add up to 360. It does. That's why there's no gaps. I can do the same with these. If I just put that together. Right. I know that's 120. That's also 120. That makes 240. And all of that is 120 as well, because that still makes a hexagon, a regular hexagon. That's 120. So 120 divided by 2 makes 60. So this angle here is 60. Okay, 60, 60 together makes 120. So what's this angle going to be? Okay, that's, if I put that, join that together, right, angles around a point add up to 360, but there's 1, 2, 3 there. There's 3 angles there, 1, 2, 3. So 360 divided by 3 is 120. So this corner is 120. I'll just write that down here. It's 120. And what did I say about this? This is 60. That's also 120. And that's 60. And you'll remember angles in a four-sided shape should add to 360. So if you add these together, they should make 360. Look, 120 plus 60 is 180. 180 plus 60, 180 plus 60 is 240. 240 add 120, 360. Let's try a different type of tessellation. Starting off with a hexagon. We know hexagons, regular hexagons do tessellate. We've just seen that. Let's see if regular hexagons and equilateral triangles, or if you like regular triangle, call it that if you want. See if it tessellates. I'm just going to try this. Now whatever I do, I need to be able to repeat the pattern in an infinite direction, but obviously I haven't got infinite number of shapes, so I'll just demonstrate with a few shapes. Right, what can I do with that? There's a gap here, so I can fill it in here nicely. It fills in. There you go. I know that it's 120 plus 120 is 240. 240 plus 60 is 300. 300 plus 60 is 360. Angles around a point out with 360. Right, you can see here I've just made one big hexagon out of these yellow and green shapes. Now if I was to make another big hexagon identical to this, and another one, I could join all those together to tessellate, because we already know hexagons, we've already seen hexagons tessellate. We saw this in the earlier part of the video, right? So if this was a giant hexagon like this one, and this one, and this one, we could carry on with this pattern. We could carry on with this pattern infinitely in all directions. Right, it doesn't have to be just hexagons that tessellate. I mean, we've got here squares and equilateral triangle. So we can fit that in here. Right, this pattern could carry on forever in all directions. Right, interesting one. These kind of look like cubes, 3D shapes, but they're not 3D. Look, it's actually flat. So I could tessellate. Right, I've got these, a square, I've got a rhombus and another rhombus joined together, but I can put them together. Watch. And you can imagine this carrying forever in all directions.